Up next, we have Nancy Huether, the Structure Management Engineer with North Dakota DOT, and she's doing her presentation on preservation strategies and implementation at North Dakota DOT.
I'm here to talk about just some of the things that we do, some of the strategies that we have for preservation of our structures, and some of the ways that we've been implementing them. Everybody knows this, but I still don't think it hurts to look at it occasionally. AASHTO defines bridge preservation as actions or strategies that prevent, delay, or reduce deterioration of bridges or bridge elements, restore the function of existing bridges, keep bridges in good condition, and extend their life. So to me, when I read that, I think about actions or strategies. And anybody that knows me knows that I preach the fact that preservation in making a bridge, basically making a bridge last for 50, 75, 100 years, begins with design. Actually, it almost begins with the planning, but we'll start with design. And if you don't have a bridge that is designed well, you are going to have a very difficult time making it last. And if you don't have a bridge that is constructed well, again, you're going to have a very difficult time making that bridge last. When we get down to the maintenance, which a lot of us think of preservation as being the maintenance, they have to take care of this bridge for a very long time. The design and construction of that bridge are very critical in making that a preservable bridge, making that last. I'm just going to talk about a few of the things that we do in the different phases of this, how we try to design so that our bridges will last a long time. We just got done talking about bridge joints in one of the peer groups, and the one that I was in. We talked about joints, and the preference always is no joints. I mean, if anybody in here had a preference or had a choice about whether to put a joint in a bridge or not, we wouldn't put them in there. They're awful. So we look at ways, like all of you do, to try and minimize our bridge joints. We began designing bridges with integral abutments in 1964 and 1965. So we've been doing that for a really long time. This is actually a little snippet from one of those original designs. Current standards, we prefer to do that when we can. The bridge length that we use, when we had a discussion there, that kind of varies. The people that were in our group, some of them went up to maybe 500 or 600 feet in length. We try to stick less than 400 feet. We have a pretty significant amount of temperature variation here. We can easily get to 100 during the summer. We can easily get down to minus 30 and below in the winter. That gives you a lot of, you need to be able to design for that expansion, contraction. If we have any kind of skew, we diminish that length, and we typically don't do an integral abutment if the skew is more than 30 degrees. So that being said, there are exceptions always to every rule, and I understand that we are currently designing one that is at least slightly more than 30 degrees with integral abutments. So I guess we'll see how that goes. We also have minimum reinforcement requirements. We require a number 5 reinforcement spaced at 1 foot in each direction or more if required by analysis. And we tie our integral abutments in the approach slabs. These are just a few more of the specifications that we have. Maximum height for an integral abutment is 12 feet. I won't go through all of these, but we have a number of different ones here. And just for fun, I threw in a picture of one of our designers. I'll let you guess which one. I think he's here, though. Some of the other things that we do are approach slabs. Any embankments that are greater than 5 feet, we put them on pile. And we've had a lot of issues with settlements of slabs, and you get the bump at the end of the bridge. We have started designing those on pile to try and help minimize that differential settlement. We tie them to the bridge, 3 foot or embedment into the deck. We use epoxy-coated reinforcement. We've been doing that for a number of years. From 1960 to 75, we used straight black bar. In 76 to 90, we used epoxy-coated rebar in the top mat only. I think this was pretty common. We're not really sure why we would have just gone to part, and I think there's in retrospect, there's a lot of people that have done it, and then you go, well, I think in the beginning, maybe the epoxy was a little bit more expensive, and there was concern about that adding to the cost, so you do it in the top because you think the chlorides are going to come down, but, once they get into there, basically in 1991, we started doing it in the top and bottom mat. I will say also that I believe we do very little with stainless, but I do believe we did a stainless clad reinforcement, design with stainless clad reinforcement, and that's fairly recent. So I don't know for sure how it's performing, but we have experimented with that a little. The cost differential for us so far, we haven't really found that we haven't gone there because of that cost differential. Also, the reinforcement, according to AASHTO standards, cover to it, epoxy-coated steel may be shown for the interior, which is up to 1.5 inches, minimum of 1.5 inches, and we use right now a 2.5-inch cover on our reinforcement. A couple of the other things that we do in design, this is a bridge that is a recently constructed bridge where we have used weathering steel. Our environment, unlike this year, a little atypical this year, typically we're a much drier climate than we have had this year. We think that the weathering steel offers some really good opportunities for us. If you can get away from having to maintain and paint bridges, we'd rather do that. Like I said, this is one of our bigger bridges that was recently constructed, and we're hoping that it performs really well. We also seal the joint between the deck and the barrier to try and keep the water out of that area, getting under the barrier around the edges of the bridge. Our wet cure requirements, we have fairly recently changed those also, and we require that they apply a wet cure within 15 minutes of the final paving. Require burlap and 2 layers of burlap. We don't allow curing compound, and we don't allow other types of curing blankets. The reason that for the burlap part of it is that it's really easy to tell if it gets dry. So we think that it's probably a way that we can make sure that we are keeping that wet, because once it dries, it's dry. You know that. 7 days minimum without fly ash and 10 days minimum with fly ash. The other thing that we do during construction is we apply a water repellent treatment. We have a spec that requires a minimum of 21 days after placement of the concrete, and we apply that treatment to the deck, the barriers, medians, approach slabs, and top and front face of the curbs. We've had a lot of barriers. Some of them may have had a minimal amount of cover over the steel, but we've had a lot of barriers where we've had issues with the slide that was shown the other day where they had the barrier on the side and then there was the curb where there was a lot thicker cover over the reinforcement, the damage that was being done there. But when you get a lot of de-icing salts and they are getting splashed onto those areas, we want to protect all of those. We use a silane water repellent, 100% solids and solvent-based. And then we get to maintenance. Unlike a lot of states, we do not have dedicated bridge maintenance crews. We did at one time. We went through some tough times. I believe in the 80s they were pretty much eliminated because we laid off people. It was a very lean time in North Dakota, and that was the area we saw fit to cut back. The maintenance crews that we have are responsible for doing all of our maintenance. That's not going to say every person does everything, but they are not dedicated to one specific thing. They share in the workload, share in the love, right? They're the same people snow plowing, doing road maintenance, roadside operations, and doing all of our bridge maintenance, the cyclical and condition-based. And we kind of pride ourselves on being very self-sufficient. We try and get them to do as much as we can. We'd rather not contract things if we don't have to, so we kind of task them with getting a lot of things done. They also, when they're not doing all of these things, provide. So some of them are maintenance activities. We do deck sealing. As I mentioned, during construction, we do it right away. We have in our bridge maintenance manual that the silane needs to be reapplied every 6 years. It really wasn't happening before. It's challenging. There's a lot of work to be done for the maintenance crews, and there's only so many people to do all of that work. And there's priorities, and I think a lot of it comes from understanding the need and the value for doing a lot of the work. In 2016, we had the first district that developed a reapplication process. They sized the tank, pumps, sprayers, and figured out the buckets that are here are catching the spray as they clean the nozzles, but they sized everything so that they could get the application right for the silane. The bottom picture is them making sure that the deck is clean and of all the debris first. They had washed the deck several days ahead of time, but they are just blowing any of the dust and stuff off, getting any of the remaining dirt off. We also, the district there, if anybody was in the joint peer exchange group that we have one district with very few bridges, and they're relatively small, and that first photo was of that district so they had a fairly small machine that they developed. Well, as you get into bigger and bigger bridges and more of them, and in some of the other districts, they decided they needed something bigger, and so they did the same thing. They're very resourceful. If they have a problem that needs to be solved, they figure out a way to do it. I could never do what the maintenance crews do. I will never discount the value that they add. Again, in 2017, then several more districts started doing this. This is another truck that they had outfitted. This truck is the one that if you were able to go to the tour, the tech tour, if you got out to look at the trucks last night, I know it was a little cool. This one is that truck. I had a video and decided I was not going to try doing a video because I know I wouldn't work. They developed a spreadsheet based on the number of nozzles they had and how much then they would need, and they have a force controller, the middle photo, if you looked at the computerized screen that they had inside the truck, this is a photo of that where they could program it into there, and then they could make sure that they get it down at the right rate. And they actually won a governor's award for this development because of the reduction in time. Silanes are great, and they can help keep the chlorides from infiltrating into the concrete. Cracks are the biggest issue. They have a direct line. As far as deep as that crack goes, that water and the chlorides, salts can just go right down and get to the rebar, get in there, cause freeze-thaw damage. And so we also have a strategy of applying crack sealing for every 3 years. We use a 2-part epoxy. We have started out with very small applications. There have been some innovative things like sitting on the chairs with rollers with the others, using the 2-part epoxy applicator with the longer stems. And maintenance is looking currently at purchasing some of the larger application machines that are used in some of the other states. Again, we just talked about joints. One of the things that we have done when we can't use older bridges that were built before the 60s where we didn't have integral abutments, we need to maintain those joints. One of our district maintenance superintendents attended the preservation meeting a year and a half ago in Florida. He had some joints that he had been having some issues with. He talked to a couple of the reps that were there and they said, we have not really, our crews have not done joint replacements, but he was ready to try it. He needed to do something. This is a picture of one of the joints on the bridge. It's not completely gone, but it doesn't look very good. And this is up in the oil country, and this bridge takes a beating. It's got truck traffic over it all the time. So they agreed to come up and help us figure out how to get these joints repaired. There's one on either end of the bridge. We had 2 different people come up and do one on either end of the bridge. They came up and helped us figure out how to do it so that we did it right, so that it's not going to fail, we hope. So far, it's been really good. This is them doing some of the prep, taking out the concrete that's failed there, the nosing concrete, prepping the joint. Here they are starting to put in a piece of wood to form the header concrete up against. There's them placing the header concrete and then finally putting in the joint. These are photos that I took recently, a year after we did this. There's some dirt in the joints. It's impossible to keep the dirt out. The oil trucks, they drive on gravel roads, and then they drive on our roads. The one thing I will note is on the left side, you can see that the dirt that's in there, I just reached down with my finger and brushed out. So it's loose, it's not caked in there. They've been keeping it clean enough so that it's not getting welded into that joint. Those are pictures of the two joints that we did. And I would like to just thank MCL and SSI for coming up and helping us with those two joints. That's just a few of the things. I just wanted to kind of share a few things, and I would love to hear more about what some of you are doing in these areas and in other areas that are things that we can do with limited, within our limitations. We have extremely resourceful people. There are bridges, and they know that, and we know that we need to take care of them. I thank you. I will answer questions if you have any. I will do my best to answer questions if you have any.
You didn't really talk about overlays. What are you doing for your overlays, and are you experiencing cracking?
We talked about this, didn't we? The only overlays that we use are typically use low slump concrete overlays. We don't do polymer overlays or anything, or traditionally haven't. We are experiencing cracking. I have heard from so many people that on new decks or overlays, they're getting more and more cracking, and we're experiencing the same thing on both new and overlays. So if anybody can solve the cracking issue or figure out what's going on, we've instituted the wet cure. We're trying really hard to approach it from there, but I don't know what's going on. But I know that's a very common problem. No, Paula, I'll let you solve that when you come back and tell me when you get it solved. Well, we're going to have to find out what Iowa's doing then. We'll expect them to come up and present on their crack-free concrete after the break. How does that sound?
Yeah.
Thank you.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.